Tonight, we are going to talk about one of the most hopeful ideas in astronomy, the search for another Earth. Somewhere in the darkness, there may be a planet with oceans, clouds, continents, weather, and a sky that does not feel completely alien. A world where sunlight touches the surface in a familiar way, where water could remain liquid, and where life, at least in theory, might have found a place to begin. But the more we search, the more unsettling the question becomes. Finding a planet the right size is not enough. Finding one in the habitable zone is not enough. Even if a true second Earth exists, it may be separated from us by distances so large that the word nearby begins to lose all meaning. So tonight, the question is simple. How far away is the next Earth? And why is that distance worse than we think? Before we begin tonight's journey, subscribe if you want more calm space documentaries like this. Leave a like if you enjoy deep space mysteries, and write in the comments where you are watching from. Tonight, you are watching the Just About Space channel, talking about the distance between us and the next Earth is worse than you think. The search for another Earth begins with a feeling more than a measurement. When people hear that astronomers are looking for Earth-like planets, the mind does not usually picture a set of numbers. It does not picture orbital periods, stellar types, radius estimates, mass limits, transit dips, or spectra gathered from faint light. It pictures something far more human, a blue world under a distant sun, a place with clouds, oceans, weather, perhaps continents, perhaps rain, perhaps a horizon that would not feel completely hostile to the eyes of someone born here. It pictures the possibility that Earth is not the only place in the universe where a world became gentle enough for life. That hope is powerful because Earth feels so natural from the inside. We wake beneath an atmosphere that has already been prepared for us by billions of years of planetary history. We breathe without thinking about pressure. We walk on a surface that holds liquid water. We live under a star at a distance, where sunlight is strong enough to warm oceans, but not so strong that the surface is sterilized. We are protected by air, by clouds, by chemistry, by gravity, by a long chain of accidents and balances that are easy to forget because they surround us every moment. To us, Earth feels ordinary because it is the only world we have ever known from the ground. But from space, Earth is not ordinary. An Earth is not just a rock. It is not just a planet with the right size. It is not even just a world in the habitable zone. The word Earth carries hidden conditions. It means a surface where temperatures can allow liquid water for long periods. It means an atmosphere that is neither too thin nor too crushing, neither stripped away nor poisonous in a way that makes the surface impossible for life as we know it. It means chemistry that can support complexity. It means a star calm enough or a planet protected enough that the surface is not constantly punished by radiation. It means a history stable enough for life to begin and perhaps remain. It means time. When we say next Earth, we are asking for more than habitability. The dream of another Earth often hides this difference. Life and home are not the same thing. A planet could host life and still be impossible for us. A world could have organisms beneath ice, in a dark ocean, under kilometers of crust, and it would be one of the greatest discoveries in history. But it would not be a second Earth in the emotional sense. It would not be a place where humans could stand beneath an open sky and feel the world accept them. It would be alive, perhaps, but not ours. This is where the search becomes quietly unsettling. We are not only searching for life, we are searching for a mirror that may not exist. The universe may have many inhabited places, but very few that resemble the one world our bodies understand. Earth did not become Earth because it checked one simple box. It became Earth because many conditions remained balanced across enormous time. The sun was stable enough. Earth was massive enough to hold an atmosphere, but not so massive that it became something else. Water persisted. Plate tectonics may have helped regulate climate over long periods. The atmosphere changed, life changed it further, and the planet entered a strange partnership with biology. A true second Earth would need its own long partnership. Not the same history, because no other world will repeat this one exactly. And the smaller the number becomes, the farther away the nearest one may be. This is the hidden fear in the title. The problem may not be that there is no next Earth. The problem may be that the next Earth could exist and still be so distant that it remains almost completely unreachable. That thought is different from simple loneliness. If there were no other Earth at all, the story would be tragic in a clean way. We would be alone in the one place that can hold us. But if another Earth does exist, somewhere in the galaxy, then the tragedy becomes stranger. A second home may be real, but locked behind distance, there may be blue skies we will never stand beneath. Oceans whose waves will never be heard by human ears. Clouds moving over continents no telescope can resolve. A living world that can exist and still never become part of human life, except as a faint signal in data. A place can be real and unreachable. That is one of space's cruelest ideas. On Earth, distance is usually temporary. A far place may be difficult to reach, but it belongs to the same planet. Ships, aircraft, roads, maps, satellites, and time can turn distant places into visited places. Even the most remote deserts, mountains, islands, and polar regions remain within one connected world. But interstellar distance is not an Earth distance stretched larger. It is a different category. It does not merely slow travel, it changes what travel means. Before we can understand that distance, we have to understand what we are hoping to find. Either answer is unsettling. Rarity makes distance worse. This is why the search cannot be reduced to excitement alone. Every new exoplanet discovery adds something to the story, but it also reveals how strange planets can be. The first worlds found around other stars were not neat copies of Earth. Many were large, hot, close to their stars, or completely unlike the worlds of our solar system. As the catalogue grew, the galaxy became richer, but not necessarily more comforting. It turned out, nature makes many kinds of planets, and most of them do not match the simple hope hidden in the phrase, another Earth. The universe is creative. That does not mean it is kind. Some planets orbit so close to their stars that a year lasts only days. Some may have atmospheres blasted away by radiation. Some are likely tidally locked, with one face turned forever toward their star. Some may be water worlds, beautiful in theory, but strange beyond human familiarity. Some are super-Earths, larger than our planet, perhaps rocky, perhaps covered in thick atmospheres, perhaps not like Earth at all despite the promising name. Some orbit stars that flare violently. Some may be in systems where gravitational interactions have shaped their histories in ways we are only beginning to understand. The more we discover, the more the word Earth-like becomes slippery. It can mean similar size. It can mean something more speculative, like having an atmosphere, water, or conditions suitable for life. But none of these meanings alone gives us Earth. They give us hints. The search for the next Earth is therefore not a search for one easy label. It is a gradual sorting of possibility, a way of asking which distant points might be more than dead rocks, more than hot spheres, more than cold shadows passing in front of stars. This is why the dream has to be handled carefully. Too much excitement can make every candidate sound like a promised land. Too much caution can make the search feel hopeless. The truth sits somewhere in between, and that is where the documentary feeling becomes strongest. There may be many worlds worth studying. There may be places where water exists, places where atmospheres survive, places where chemistry becomes complex, places where life has begun in ways we cannot yet imagine. But the next Earth, in the deep human sense, may be far rarer than the headlines suggest. It may not be the nearest planet. It may not be the nearest rocky planet. It may not be the nearest world in the habitable zone. It may be much farther away, hidden among stars that look ordinary from Earth, separated from us by light years that turn hope into patience. This is where the search begins to change shape. At first, another Earth feels like an answer to loneliness. Then it becomes a test of scale. The question is not only whether such a world exists, but how far away the nearest true candidate might be. If it is 4 light years away, it is still beyond any human journey we can make now. If it is 40 light years away, it becomes more remote than most people can emotionally process. If it is 400 light years away, it may be observable but unreachable in any practical sense for a very long time. If it is thousands of light years away, then it belongs to astronomy, not migration. A telescope can make a world known. It cannot make it near. That may be the central sadness of the next Earth. We may discover signs that make a planet seem promising. We may measure its size, estimate its orbit, study its star, and one day perhaps detect gases in its atmosphere that suggest water, chemistry, or even life. We may know enough to suspect that somewhere, under another sky, there is a world not completely unlike our own. But knowing would not give us a path. It would give us awareness. Awareness can be beautiful. It can also be painful. To know that another Earth exists would be one of the greatest moments in human history. It would mean the conditions of our world are not unique. It would mean the galaxy has produced at least one other place that resembles the only home we know. But if that world lies beyond reach, the discovery would carry a quiet ache. It would be like seeing a light in a window across an ocean no ship can cross. There is comfort in the light. There is pain in the ocean. This is the emotional shape of the entire journey. The next Earth is not just a planet. It is a symbol of possibility. But distance changes possibility. It can turn a second home into a distant fact. It can turn hope into observation. It can turn the word nearby into something that only astronomers can say without feeling the human weight of it. In astronomy, nearby can mean light years. To the body, nearby means footsteps, roads, voices, warmth. These two meanings do not belong to the same world. The body still belongs to Earth. The telescope belongs to the stars, and the mind is trapped between them. That is why the first part of the story has to begin with the dream itself. Before numbers, before catalogues, before named candidates, before Proxima b, before red dwarf problems, before light years and generation ships, we have to sit with what we are actually asking for. We are asking whether the universe has made another place where the idea of home could happen again. Not just a surface, not just an orbit, not just a temperature range, but a world that could carry softness in a cosmos, mostly made of extremes. A world where water might move, a world where clouds might form, a world where the star is not too cruel, a world where the surface is not only a surface but a stage for chemistry, weather, and time. That is an extraordinary demand. It may be answered somewhere, but the answer may be far away. The galaxy is wide enough to hold hope and still make hope unreachable. That is the mood we have to carry forward. The next Earth may not be a fantasy. It may exist around a faint star we have already catalogued, or around a sun-like star whose light has crossed space for decades or centuries before entering our instruments. It may be waiting not as a place waiting for us, but as a place simply being itself, with or without observers, with or without any future human arrival. The next Earth does not have to know we are looking. It does not have to be close. It does not have to be usable. It only has to exist, and that is what makes the search so haunting. We are not guaranteed a second home. We are not guaranteed that the nearest promising planet is truly habitable. We are not guaranteed that life, if it exists elsewhere, lives on surfaces like ours. We are not guaranteed that the universe repeats Earth often enough for one to sit within reach. We are looking into the dark with instruments, hope, caution, and the knowledge that even success may not solve the distance. This is not a reason to stop searching. It is the reason the search matters, because every candidate teaches us what Earth is by contrast. A hot world teaches us about balance. A frozen world teaches us about warmth. A stripped world teaches us about atmosphere. A red dwarf planet teaches us about stellar violence and survival. A rocky planet in the habitable zone teaches us that possibility is not the same as certainty. Each discovery narrows the question not only of where another Earth might be, but of why this Earth became possible. The next Earth, wherever it is, may be the greatest mirror humanity ever finds. But mirrors can be far away. And before we can face the distance to that mirror, we have to face another uncomfortable truth. After thousands of discovered planets, we still have not found a true second Earth. That sentence sounds strange at first. It seems almost impossible that the galaxy can be filled with planets, and yet, the one kind of world we most hope to find remains out of reach. For centuries, humanity did not know whether planets around other stars were common at all. The stars were lights in the sky, suns in theory, but their worlds were hidden. Then, slowly, with better instruments and patient observation, the darkness around other stars began to reveal itself. Tiny dips in starlight, subtle gravitational tugs, repeated signals, patterns too faint for the human eye, but clear enough for science to say, there is a planet there. And then another, and another. It gave us variety. At first, that variety is exciting. It tells us nature is creative. It tells us the galaxy is not built from one simple design, repeated endlessly. It tells us worlds can exist in forms no one expected before the first discoveries. But after the excitement comes something quieter. If planets are common, but Earth-like planets are hard to confirm, then the problem becomes more precise. The galaxy may be full of worlds, but most worlds may not be homes. This is the second uncomfortable truth. A planet is not a promise. A planet is only a place where possibility begins. A distant planet can be measured without being understood. A true second Earth would require more than a promising measurement. It would need a world behind the measurement, a surface, an atmosphere, long-term stability, the right relationship with its star, perhaps weather that does not destroy the conditions it creates. Each discovery widens the gallery. Each discovery also reminds us that Earth is not the obvious template. That is the unsettling reversal. We often begin by treating Earth as normal and asking how many other Earths exist. But exoplanets force a different thought. Earth may be one outcome among many, and perhaps not the most common one. A planet can be rocky without being Earth. It can be close in size without sharing Earth's surface conditions. It can be temperate in theory, but unstable in reality. It can receive the right amount of light and still fail to become a world where life can flourish on the surface. The galaxy may not be searching for Earth with us. Thousands of non-Earths can make it feel colder. This is where the emotional meaning of discovery becomes complicated. A headline about a potentially habitable planet can feel like a door opening. For a moment, the mind sees another world waiting in the dark. But beneath the headline are uncertainties. We may know the planet's size, but not its atmosphere. We may know its orbit, but not its surface. We may know its star, but not whether the star has stripped the planet bare. We may know it could have the right temperature in a simple model, but not whether it has water, pressure, chemistry, or protection. The possible world remains behind a veil. Sometimes it is the limits of our instruments. A true second Earth would have to reveal itself through traces before it ever became an image. It may also be one of the most emotionally distant. The distance between evidence and experience is enormous. A scientist can look at a light curve and see a planet. A viewer at home wants to see a world. Both responses are valid, but they are not the same. The light curve is the beginning of knowledge. The imagined world is the beginning of longing. Between them lies uncertainty, and uncertainty is where the next Earth keeps hiding. What exactly counts as the next Earth? If we find a planet the same size as Earth, but dry and dead, is it a next Earth? If we find a water world twice Earth's mass, full of ocean but with no land, is it a next Earth? If we find a planet with microbial life under ice, around a red dwarf, is it a next Earth? If we find a rocky world with oxygen in its atmosphere, but intense radiation at the surface, is it a next Earth? If we find a place where life exists but humans could never walk outside, is that what the dream meant? It may be several different hopes disguised as one. There is the scientific hope, a planet where life exists. There is the human hope, a planet that feels like home. There is the survival hope, a planet where humans could someday live. There is the emotional hope, proof that Earth is not alone. These hopes overlap, but they are not identical. A planet could satisfy one and fail the others. That is why thousands of exoplanets have not ended the search. They have multiplied the questions. Perhaps the first living world we find will not be Earth-like. The universe does not owe us the version of the answer we want most. That is why the phrase, "No true second Earth" matters. It does not mean no promising worlds exist. It does not mean the search is empty. It means the specific thing we are dreaming about remains unconfirmed. A planet genuinely close enough to Earth in the ways that matter most, with evidence strong enough to make the comparison more than hopeful. Language. We have candidates, possibilities, hints, and targets. We have reasons to keep looking. But the mirror has not yet appeared clearly. The mirror may be there, but it has not turned its face toward us, trying to recognize another Earth from clues. That reversal is humbling. It reminds us that if there is another living world out there, it may not look obvious from here. It may hide behind its star's glare. It may not transit from our point of view. Its atmosphere may be difficult to study. Its signals may be faint or ambiguous. It may be alive in ways that do not produce the signs we expect. Or it may be Earth-like, but too far away for current instruments to read clearly. The absence of proof is not proof of absence, but it is still an absence we feel. The search, therefore, lives between patience and ache. Patience, because astronomy often advances by decades of careful work, better telescopes, more sensitive instruments, and slow confirmation. Ache, because the human question is simple and urgent. Is there another world like ours? The universe answers slowly. It answers in candidates, not certainties. It answers with probability, not comfort. It answers by showing us many worlds and leaving the one we want most still uncertain. This can make the galaxy feel strangely indirect. It is not silent, it is speaking through data. But the answer is not yet clear. Every planet discovered adds a syllable to a sentence we cannot fully read. Some syllables sound promising, some sound strange, some sound hostile. Some may one day be reread with better instruments and become more important than they first appeared. The story is still forming, and that is why the search for the next Earth remains alive. We are not staring into nothing. We are watching a picture develop slowly in darkness. But the slow development also reveals a sobering truth. Quantity is not the same as similarity. 1,000 worlds do not automatically produce one home. 10,000 worlds may still require careful sorting. A galaxy can be rich with planets and poor in places that resemble Earth closely. Or perhaps true Earths are common, but hard to detect because they are small, distant, and hidden by the brightness of their stars. Both possibilities leave us in tension. Either the next Earth is rare, or it is difficult to see. Either way, the distance between hope and confirmation remains wide. That is a different kind of distance from light years. It is the distance between knowing planets exist and knowing one of them is like home. This distance can be felt even before we talk about travel. It is a distance in evidence, in certainty, in imagination. The planet may be physically out there, but until we can understand it, it remains emotionally far away. A candidate can sit in a catalogue and still not become a world in the human mind. A promising orbit can excite scientists and still fail to become a place people can imagine sleeping under a sky. The next Earth must cross two distances: the physical distance between stars and the informational distance between hints and certainty. The second one comes first. Before anyone dreams of traveling, we have to know what we have found. Is it rocky? Does it have air? Does it have water? What kind of star does it orbit? Is the atmosphere stable? Is the surface protected? Are there signs of chemistry that might point toward life? Are there false positives? Are there explanations that do not require biology? Is the world truly Earth-like or only Earth-sized? The questions multiply because the comparison is so important. Calling a world another Earth too early would be a mistake, but never allowing the dream to breathe would also be a mistake. This is the careful balance the search requires. We need imagination to care about distant planets, but caution to understand them honestly. We need to be excited by candidates without pretending they are confirmed homes. We need to let the phrase, "Next Earth," remain powerful while remembering how much it must prove. It is hope under discipline, a calm hope, a patient hope, a hope that knows the universe is not required to be convenient, and that hope is still worth having. Because even without a confirmed second Earth, the catalogue of exoplanets has already changed the human story. We no longer look at the stars as lights that may or may not have worlds. We know worlds are there. We know planet formation is widespread. We know the galaxy has produced a vast range of planetary environments. We know Earth is not alone in being a planet. The remaining question is whether it is alone in being this kind of planet. That question has become sharper than ever. Sharper and more haunting. The search has moved from whether planets exist to whether homes exist. Not homes for humans necessarily, not places we can easily reach, but worlds where the conditions of Earth have some echo. A planet with a surface and sky. A planet where water might persist. A planet where chemistry could become biology. A planet where the word Earth-like means more than a hopeful approximation. After thousands of discoveries, we have learned that the galaxy is full of planets. We have not yet learned that it is full of Earths. That difference is the reason the journey must continue. The next Earth, if it exists, may be hidden among ordinary-looking stars, too faint to reveal itself clearly with the instruments we have now. It may be close by astronomical standards and still unreachable. It may be far away and easier to understand than to visit. It may orbit a red dwarf, raising difficult questions about flares and atmospheres. It may orbit a sun-like star, making it more familiar in some ways, but perhaps much farther from us. Whatever it is, the search will not be solved by the word planet. It will be solved by conditions, by atmosphere, by light, by chemistry, by time, by the slow building of evidence until a distant point becomes something more than a candidate. This is why the thousands of planets we have already found do not weaken the mystery. They strengthen it. They show that the universe has enough worlds to make another Earth possible, but enough variety to make it uncertain. They show that our hope is not foolish, but not guaranteed. They show that a second Earth may be somewhere in the dark, but not necessarily nearby, not necessarily obvious, and not necessarily shaped in a way our first expectations can hold. The catalogue is not the answer. It is the beginning of the search becoming serious. And once we understand that thousands of planets have still not given us a true second Earth, the next question becomes even more important. What does it really mean when a world is called habitable? Habitable feels almost like a promise. It suggests a world that could be lived on, a place where oceans might shine under an alien sun, where clouds could move through the sky, where the surface might hold the kind of softness that makes Earth feel familiar. It is one of the most powerful words in astronomy because it turns a distant planet from a point of data into a possible place. The moment we hear that a world lies in the habitable zone, the imagination begins to build a landscape. But the habitable zone is not a promise. It is only a beginning. It can orbit in the habitable zone and still be stripped nearly bare by its star. It can orbit in the right place and still fail to become anything like Earth. This is the quiet danger of the phrase. It compresses many uncertainties into one hopeful label. A star has a certain brightness. A planet orbits at a certain distance. Based on that relationship, scientists can estimate whether the planet receives an amount of energy that could, in principle, allow liquid water. But the planet itself remains far more complicated than its distance from the star. A world is not habitable because of one number. It is shaped by atmosphere, pressure, chemistry, rotation, geology, magnetic environment, impact history, and time. This matters even more around other stars, because stars are not all like the Sun. Some are larger, brighter, and shorter-lived. Some are smaller, cooler, and far longer-lived. Some flare more strongly. Some bathe nearby planets in high-energy radiation. Some change their brightness over time in ways that can reshape the futures of their worlds. A habitable zone around one kind of star is not the same as a habitable zone around another. The distance changes, the light changes, the risks change, and the planet's environment changes with them. A planet can be in the zone and still live under a cruel star. A red dwarf planet in the habitable zone can sound hopeful. It can also be a world of extremes. This is why the next Earth may be harder to identify than the next planet in the habitable zone. A habitable zone planet is a candidate for deeper attention. It is a world that deserves study, not a confirmed home. It tells astronomers where to look more carefully. It does not tell us whether there are oceans, continents, breathable air, clouds, seasons, or life. It does not even guarantee the planet has an atmosphere at all. A planet's surface may be hidden completely. Its atmosphere, if present, may be faint in the data. Its clouds may confuse interpretation. Its star may be too active or too bright for clean measurements. The planet may not pass in front of its star from our point of view, making some methods impossible. Even when we can study starlight passing through a planet's atmosphere, we are not looking at a world the way we see Earth from space. We are reading traces. The next Earth, if found, may first appear as a fragile clue, a slight signal. But gases can mislead. Oxygen can be produced by life, but there can also be non-biological processes that create oxygen under certain conditions. Methane can be biological or geological. Water vapor may indicate water, but not necessarily oceans. Carbon dioxide can help warm a world or become part of a hostile greenhouse state. Every possible sign must be questioned because the universe is good at creating false hope for simple stories. The more important the claim, the more carefully it must be tested. To say that a planet is in the habitable zone is one thing. To say it may have an atmosphere is another. To say it may have water is another. To say it may support life is far more serious. And to say it is a true second Earth would require a level of evidence that is still beyond what most distant planets can give us. A habitable zone discovery tells us that a world is worth watching, but it does not yet tell us whether the world is alive, gentle, stable, or safe. It may be a promising candidate. It may be a disappointment. It may be something stranger than either. It may force us to rethink what habitability means. It may be a place where life could exist only underground, or underwater, or at the boundary between day and night, or in forms that do not match Earth's surface life at all. If life exists elsewhere, it may not be waiting on a blue-green planet under a yellow sun. It may live around red dwarfs, under ice, inside deep oceans, in thick atmospheres, or in chemical environments that feel alien to us. The first habitable world we truly understand may not look like home. It may expand biology while failing the emotional test of the next Earth. It may tell us life is common, while still telling us human homes are rare. Because the title is not asking only whether life exists, it is asking how far away the next Earth is. And Earth means more than life. It means a world where the conditions resemble the one that shaped us. It means a surface that is not only chemically interesting, but stable enough for complexity. It means a star that does not make the sky into a constant threat. It means water that can remain, air that can protect, geology that can support long cycles, and time enough for the planet to become more than a brief possibility. This is why astronomers often speak carefully. They know that habitability is not a single switch turned on by distance. It is a system. A planet must hold together many conditions at once. It must not only receive energy, but process it. It must not only have chemicals, but cycle them. It must not only have water, but keep it available. It must not only have a surface, but keep that surface from being destroyed, sterilized, frozen, or buried beneath impossible pressure. A living world is not a point in space. It is a balance. This is where the idea becomes darker, but also more honest. The distance to the next Earth may not only be measured in light years. It may be measured in the number of failed balances between here and there. A planet around a nearby star may have the right orbit, but the wrong atmosphere. Another may have the right size, but the wrong star. Another may have water, but no stable surface. Another may have an atmosphere, but too much radiation. Each one can be close to the dream in one way, and far from it in another. The next Earth may be distant, because the required combination is rare. That word is more frightening than impossible in some ways. Impossible would close the story. Rare keeps it open while stretching it painfully. Rare means somewhere perhaps a world exists with the right conditions. Rare means the search matters. Rare means the next Earth may be out there. But rare also means it may not be close. It may not be one of the first candidates. It may not orbit the nearest star. It may be hidden among thousands of worlds that are interesting, but not enough like home. This is why habitable zone planets should not be dismissed, but also should not be romanticized. They are not false hopes. They are incomplete hopes. Each one is a question the universe has allowed us to ask. Could this world keep air? Could it hold water? Could it survive its star? Could chemistry move there? Could life begin? Could the surface stay stable long enough? Could it be a place where biology changes the planet, as biology changed Earth? These questions are worth asking, even when the answer is no. Every no teaches us something about the difficulty of yes. The next Earth will be understood through many worlds that are not it. That is a slow way to search, but it may be the only way. We may have to study hot worlds, frozen worlds, red dwarf worlds, super-Earths, mini-Neptunes, dry rocks, ocean candidates, and atmospheric puzzles before we can recognize the one that truly matters. The next Earth may not announce itself as a perfect twin. It may look uncertain at first, then become more convincing as instruments improve. Or it may remain ambiguous for generations, with each telescope adding another layer of evidence. The search is not a single discovery. It is a long narrowing of doubt. This makes the habitable zone feel less like a green ring around a star and more like a doorway into uncertainty. It tells us where the dream might begin, not where it ends. The planet inside it may be dead. It may be alive. It may be strange. It may be a warning. It may be a mirror. It may be a world that forces us to separate the search for life from the search for another home. The habitable zone, then, is not a promise of safety. It is a scientific hint, a place where a certain kind of question becomes reasonable. It lets us choose targets from the darkness. It helps us decide where to point telescopes, where to search for atmospheres, where to look for the chemical fingerprints of water and life. It is one of the most important concepts in the search for another Earth, but it is also one of the easiest to misunderstand. It is only the region where, if many other things are right, a world might avoid being too hot or too cold for surface liquid water. That definition is powerful, but narrow. It leaves out almost everything that makes Earth Earth. It leaves out the story. It leaves out the atmosphere. It leaves out the geology. It leaves out the biology. It leaves out the long survival of balance. It must also be old enough for its story to unfold, stable enough for conditions to persist, and quiet enough around its star that its surface does not become a battlefield between radiation and atmosphere. It must avoid too much, keep enough, lose the right things, hold the right things, and perhaps develop life that changes it in ways we cannot predict. It must be lucky not once, but over and over again. That may be the most important difference. A planet can begin promising and fail. A true Earth-like world must remain promising long enough for possibility to become history. That history is what we cannot easily see from far away. A telescope may tell us where a planet is today, but the deeper question is what it has survived. Did it lose oceans? Did its star flare violently in its youth? Did its atmosphere collapse? Did greenhouse warming take over? Did impacts reset its surface? Did chemistry ever cross into biology? The habitable zone can point to the question. It cannot answer it alone. This is why the distance to the next Earth becomes worse than we think. Because before distance even means travel, it means uncertainty. The planet may be there, but hidden behind a star's brightness. It may be promising, but not proven. It may be in the right orbit, but wrong in ways we cannot yet measure. It may be called habitable because of where it is, while the reality of the world remains sealed away by light years. The first distance is not between Earth and the planet. It is between the label and the truth. And once that is understood, the search grows more serious. We stop treating every habitable zone world as a potential escape and begin treating it as a mystery. Some mysteries may disappoint us. Some may surprise us. Some may become more Earth-like as we learn more. Others may become less. The hope remains, but it becomes slower, calmer, and more honest. The next Earth, if it exists, will not be found by hope alone. One by one, these illusions have to fall away, not to destroy the dream, but to reveal what the dream actually requires. Only then can the distance to the next Earth be understood. It is not just a distance across space. It is a distance across conditions, evidence, time, and trust. We are not only asking where the next Earth is, we are asking how many fragile pieces of reality have to align before a planet becomes worthy of that name. And when those pieces do align, they may not do so near us. That is the thought waiting beyond the habitable zone. Even the closest promising worlds may carry problems we cannot solve from a distance. Even the most exciting candidates may turn stranger under better observation. The search has to continue outward, star by star, signal by signal, through hope and correction. And eventually, it brings us to the nearby worlds that seem like our first real chances, only to show that nearby in space can still mean impossibly far from Earth. The closest hope may still be too far. That is where the search for the next Earth becomes emotionally difficult. It is one thing to imagine a second Earth, somewhere deep in the galaxy, hidden among billions of stars, so distant that it belongs more to philosophy than to travel. A faraway world can remain abstract. It can be beautiful in the mind, precisely because it is not close enough to disturb us. But the closest candidates are different. They are the ones that make the dream feel almost possible. They sit near the front of the cosmic map, around stars whose names can be spoken without feeling entirely mythical. They seem to offer the first real chance. And then the distance appears. Even the nearest hope is not near. It was there, around the nearest star. That should feel comforting. This is the first reason the closest hope may still be too far. The universe measures closeness with light. Human beings measure closeness with bodies, lifetimes, and reachable journeys. A telescope can receive light from Proxima. A spacecraft cannot simply follow that light at the same speed. Even our fastest probes move at a tiny fraction of light speed. They can cross the outer solar system over decades. They can leave the planets behind. They can drift into interstellar space. But reaching another star is a completely different scale of movement. That is why Proxima Centauri b is so haunting. It feels like a doorway, but the doorway is on the other side of an ocean, wider than any human experience. The planet may be close enough for us to study with instruments, to dream about, to model, to argue over, to wonder whether it has an atmosphere, whether it could hold water, whether its star has made the surface too hostile. But it is not close enough to visit, in the way Mars is close enough to imagine visiting. It is not a destination waiting just beyond the next engineering step. It is a symbol of the gap between seeing and going. This gap matters because the search for the next Earth often begins with the emotional idea of escape. If Earth is fragile, perhaps there is another home. If our planet changes, perhaps we could go somewhere else. If humanity survives long enough, perhaps a second Earth becomes a future refuge. But the closest possible Earth-like candidates teach a hard lesson. Finding another world does not make it available. Discovery is not access. Awareness is not rescue. A planet can be real and still useless as a lifeboat. That may be one of the most important truths in all of exoplanet science. Another Earth, even if found, would not automatically solve anything on Earth. If it lies light years away, it cannot catch us if we fall. It cannot protect us from our own mistakes. It cannot become a backup planet in any simple sense. It may change our understanding of life in the universe, but it would not give us an easy second chance. This does not make the search pointless. Even the nearest star keeps its distance. That is not failure. That is reality. The gap between knowledge and experience remains almost total. A planet around the nearest star is still, mostly, a mystery. This is not because science is weak. It is because the universe is large and planets are small. Stars are bright, planets are faint, and atmospheres are thin compared with the size of space. To learn about a world across light years, we must read tiny changes in light, extract faint signatures, remove noise, and build careful models. Even then, certainty is hard. We may learn enough to say a planet is promising. We may learn enough to say it is unlikely. But turning it into a fully known world is another level of difficulty. There is the observational distance. That is why the next Earth cannot be treated like a simple map location. A close candidate does not remove uncertainty. The closest hope becomes a mirror of uncertainty. The word next begins to lose comfort. Next does not mean near. It only means nearest of its kind. That gap between candidate and answer may define the next century of exoplanet science. We may spend years examining nearby red dwarf planets, trying to understand whether their atmospheres survive. We may study systems like TRAPPIST-1, where multiple Earth-sized planets orbit a cool star and still face the same hard questions about atmospheres, radiation, water, and long-term habitability. We may discover new nearby worlds that seem promising, only to learn that they are too hot, too cold, too dry, too massive, too irradiated, or too strange. This is not discouraging in the simple sense. It is how the search becomes real and still be valuable. But it would also leave the ache. If the closest candidate is not enough, then where is the next one? That question has no comforting answer yet. It pushes the search outward to other nearby stars, then farther stars, then wider surveys. It asks us to examine small rocky planets around different kinds of stars. It asks us to compare red dwarfs with sun-like stars, close candidates with distant analogues, easy-to-detect worlds with harder, quieter targets. It asks us to keep looking even when each promising world becomes more complicated under scrutiny. Hope, measurement, complication, correction. Hope again. The next Earth will not be found by refusing disappointment. It will be found by surviving disappointment. Astronomy has always worked this way. The universe gives hints, and the first interpretation often changes. A point becomes a planet becomes a class becomes more varied than expected. A promising idea becomes narrower, then stronger. The search for Earth-like worlds will likely follow the same path. The early candidates will teach us how to ask better questions. The nearest hope, then, is not only a possible destination in thought, it is a teacher. It teaches us that close is relative. It teaches us that habitable zone does not mean habitable. It teaches us that red dwarf worlds may be both common and difficult. It teaches us that even if another planet lies around the nearest star, the path from detection to understanding is long. It teaches us that interstellar distance begins hurting before we even try to travel, because it limits what we can know. This is a different kind of far. A world can be far from our hands, but also far from our certainty. The closest hope is too far in both senses. Too far for our spacecraft, and perhaps still too far for our understanding. We can point to it, model it, search for signals, and imagine it under its red star. But the real planet remains itself, silent and distant, untouched by our desire to make it the answer. It does not become a second Earth because we need one. It does not become safe because it is close. It does not become clear because it is famous. The planet owes us nothing. That thought may feel cold, but it is necessary. The search for another Earth is not a story where the universe rewards our longing with the nearest possible answer. It is a story where reality must be met on its own terms. The closest world may be strange, the promising world may be hostile. The true Earth-like world may be hidden far away. And even if we find it, the light reaching us may only tell us what it was years, decades, or centuries ago, depending on how distant it is. Every discovery arrives late. Even light takes time. This makes the idea of a nearby Earth-like planet even more haunting. If we see it 4 light years away, we see it as it was 4 years ago. That delay is small compared with many cosmic distances, but it still reminds us that astronomy is always a study of the past. For more distant candidates, the delay grows. A planet 40 light-years away is seen as it was 40 years ago. A planet 400 light-years away is seen from before modern history's latest chapters. A planet thousands of light-years away may be a present reality whose light belongs to an older Earth. The next Earth, if found, will arrive to us as old light, not a live view, not a window we can step through, a message already delayed by space. This does not make the discovery less meaningful. It makes it more delicate. We are always touching the universe through time. The light from a candidate planet crosses the dark, carrying information, and by the time it reaches our instruments, the world may have changed in small or large ways. Its atmosphere may have evolved, its star may have flared, its climate may have shifted, its life, if any, may have changed. We would know the planet through a delayed whisper. The closest hope whispers after only a few years. The farther hopes whisper after generations. That difference matters, but neither whisper is a handshake. Both are distant. Both require interpretation. Both remind us that the next Earth, if it exists, will not first come to humanity as a place, but as light, a slight dimming, a spectrum, a chemical hint, a set of careful probabilities. The dream of a living world may begin not with a photograph of blue oceans, but with a line in data that refuses to be ignored. This is the calm strangeness of modern astronomy. The greatest hope may arrive as a tiny measurement. The next Earth may first appear as almost nothing, and from almost nothing, the mind will build a world. That is beautiful, but dangerous. We have to build slowly, too quickly, and we turn candidates into fantasies. Too slowly, and we fail to feel the wonder. The closest hopes ask us to do both at once, to be moved and cautious, to feel the possibility without pretending it is solved. Proxima b, nearby red dwarf worlds, and future discoveries around nearby stars all live in that tension. They are close enough to make us dream, too far away to answer easily, and possibly too strange to become the dream itself. That final possibility is the hardest one. The closest hope may still be too far, but it may also be the wrong kind of hope. It may teach us about the galaxy without giving us comfort. It may show us that planets are everywhere, while Earth remains rare. It may reveal that the nearest systems are rich with worlds, but not with homes. It may tell us that the universe is full of places, and yet the place we need may be far beyond the first ones we find. A galaxy full of planets is not the same as a galaxy full of homes. The nearest star may have planets. The nearest planets may have stories. The nearest stories may not be ours. That is why the search must keep moving outward. Not because the closest candidates are unimportant, but because they may be only the opening questions. The next Earth, if it exists, may require us to look past the first hope, then past the second, then past many almost right worlds. It may force us to learn patience on a galactic scale. It may teach us that Earth is not simply a planet in the right place, but the result of many conditions surviving together for an almost unbearable length of time. If a world like that exists near us, it would be one of the greatest gifts the universe could give. If it does not, then the search becomes longer, and the distance becomes worse. The closest hope may still be too far, because close, in astronomy, is not human close. 4 light-years is close to a galaxy, but not to a civilization with rockets that still measure missions in years and decades. A nearby candidate is close to our telescopes compared with the rest of the Milky Way, but not close to our bodies. It can be near enough to study, and still impossibly far to reach. It can be close enough to inspire, and still too distant to save. This is the truth that waits around the nearest stars. They are not empty. They may have worlds. They may even have worlds that make us wonder about water, atmospheres, and life. But wonder is not arrival, and nearby is not near. The journey toward the next Earth, therefore, passes through a painful realization. The first promising worlds may only show us how far away the real answer remains. The nearest star becomes not only a destination in thought, but a measuring stick for our limitations. If even that star is too far, then what does it mean to speak of a second Earth at all? If even the closest hope cannot truly be reached, then every farther hope begins to feel like a message from a future we may never enter. And that is why the next part of the journey must slow down and face the unit that makes all of this so difficult: the light year itself. The light year sounds almost gentle, It has a softness to it, because the word year belongs to human life. A year is something we understand. A year can hold seasons, birthdays, winters, summers, memories, changes, and plans. A year can be imagined because we live inside them, one after another. It is long, but not impossible. It is part of the rhythm of being alive on Earth. But a light year is not really about a year. It is about light. It is about the distance light can travel in 1 year, moving at the fastest speed the universe allows. Light can cross from the moon to Earth in a little more than a second. It can cross from the sun to Earth in about 8 minutes. It can move through the solar system with a speed that makes human travel look almost motionless. And still, when it comes to the stars, even light needs years. When we hear that a possible nearby world is 4 light years away, the number seems small at first. 4 is a human number. 4 steps. 4 days. 4 years. 4 sounds manageable until we remember what is being counted. It is not 4 years of ordinary travel. It is 4 years of light crossing empty space at nearly 300,000 kilometers every second, without stopping, without turning, without needing fuel, without carrying mass in the way a ship does. This is where ordinary imagination begins to fail. A kilometer is already something the body can understand. A city can be measured in kilometers. A road trip can be measured in hundreds of them. The moon is far, but we have crossed that distance with humans. Mars is far, and even Mars becomes a long, dangerous journey of months. The outer planets become years of robotic travel. But a light year is not the next step after those distances. It is the moment the scale changes completely. The solar system is already enormous. Light from the sun takes minutes to reach Earth, hours to reach the outer planets, and far longer to reach the distant edges of the sun's influence. Spacecraft can spend years moving through the planetary region and still be considered close to home on the scale of stars. But once we speak in light years, the solar system becomes a small local pocket, a bright neighborhood around one star, surrounded by distances so large that even our farthest machines have barely begun. This is why the next Earth becomes such a difficult idea. If a promising planet is a few light years away, it is close enough for astronomy to feel excited. It is close enough that its star belongs to our local stellar neighborhood. It is close enough that future telescopes may study it more carefully than more distant worlds. But it is not close enough for human instinct. Human instinct was built for landscapes, not light years. It was built for horizons, paths, rivers, forests, mountains, shelters, and visible movement. It was not built for distances where the fastest thing in nature becomes the measuring stick. It tells us that the universe is not scaled for us. It tells us that the space between stars is not like the space between islands or continents. It tells us that the word nearby has been taken away from the body and given to mathematics. A star can be nearby while still being unreachable. A planet can be close while still being a dream. A signal can arrive while any possible journey remains beyond the shape of a human lifetime. That is why light years feel calm and terrifying at the same time. They are calm because they are precise. They give order to the dark. They let astronomers compare distances, build maps, place stars, and speak clearly about the galaxy. But they are terrifying because they make the truth readable. They take the emotional darkness of space and give it a number. They tell us exactly how far the hope is, and the exactness does not make it easier. It makes it harder to escape. The words become simple, almost too simple, but each one hides a distance that no human being has ever crossed. Even the nearest of them belongs to a category beyond all past travel. We can launch probes into interplanetary space. We can send machines beyond the planets. We can watch them continue outward until their signals fade. But the space between stars is not merely more space. It is a different kind of emptiness, so wide that our machines begin to feel symbolic. This is why the idea of a second home becomes so haunted by numbers. It is not enough to ask whether another Earth exists. We must ask where. If it is 4 light years away, it is almost impossibly close by cosmic standards, and almost impossibly far by human standards. If it is 40 light years away, light itself takes decades to bring us its image. If it is 400 light years away, the information arrives from a time before many lives now being lived had even begun. If it is thousands of light years away, the world may be scientifically real, while belonging to a distance that feels nearly mythological. The farther the next Earth is, the more it becomes a message rather than a place. That is a painful distinction. A place is somewhere you can imagine going. A message is something you can receive. The next Earth may come to us first as a message in starlight, a slight change in brightness, a spectrum, a chemical hint, a sign that some distant world has air or water or something stranger. But a message does not become a road. It gives knowledge, not access. It can change the mind without changing the body's situation at all. A light year makes that separation unavoidable. It reminds us that seeing is not reaching. The night sky makes this easy to forget. Stars appear scattered across the darkness, like lights on a distant hill. Some look brighter, some fainter, some warmer, some colder. But the sky flattens them into a single surface. It does not show depth properly. It does not show the gulfs between one star and another. It does not show that a star that looks close to another in the sky may be nowhere near it in space. The human eye turns the galaxy into a ceiling. A light year pulls the ceiling apart. Suddenly, the stars are not lamps on a dome. They are suns separated by vast, invisible intervals. The darkness between them is not a background. It is the main structure. Most of a journey between stars would not be arrival, departure, or approach. It would be crossing the between, moving through a region where the destination remains a point for almost the entire voyage. The traveler would spend nearly all of the journey surrounded by no nearby world at all. This is the part of interstellar distance that the mind resists. We imagine leaving Earth, passing planets, then approaching another star in a grand cinematic arc. But the real journey would be dominated by emptiness. The solar system would shrink behind the ship. The target star would remain tiny ahead. Years, decades, centuries or longer could pass with almost no change visible to the human eye. Motion would be real, but the scale would make it feel still. The ship would be moving, yet the universe would seem not to care. This is where the light year becomes psychological. It is not just how far the next Earth may be. It is how long nothing happens on the way. Human beings need markers. We need progress we can feel. On Earth, a journey gives us changing landscapes, towns, weather, roads, signs, sounds, and bodies of water. Even long ocean voyages had waves, storms, stars, and the sense of being on a living planet. Interstellar travel would offer almost none of that. The markers would be internal, fuel remaining, systems aging, clocks advancing, distance calculations changing slowly. Outside, the view might remain almost unchanged for longer than a life can comfortably imagine. A light year is distance turned into patience, and patience becomes frightening when it outlives the traveler. The stars are not made close by ambition, they must be made close by physics. And physics is not easily negotiated. This is why the next Earth may be close enough to detect and too far to matter practically. That sentence feels harsh, but it may be true for a long time. Detection belongs to astronomy. Travel belongs to engineering, biology, society, and survival. Astronomy can reach with light. A telescope does not need to carry air, food, water, radiation shielding, or sleeping humans. It only needs to gather photons, It can let the universe come to us in faint signals. Travel must go the other way. It must push matter across the gulf. It must protect that matter. It must keep it organized and alive. A telescope can cross light years without moving. A ship cannot. This is why our first contact with the next Earth, if it ever comes, will almost certainly be observational. We may see its shadow against its star. We may detect molecules in its atmosphere. We may infer surface conditions. We may build maps from tiny variations in reflected light. One day we may argue over whether the signals suggest life. The world may become famous while remaining untouched. It may become one of the most important places in human thought without ever becoming a place in human experience. The emotional force of that idea depends entirely on the light year. Without it, the next Earth would be like a distant continent, difficult, but ultimately reachable. With it, the next Earth becomes something else, a place that may exist within the same galaxy, perhaps even within the same local neighborhood of stars, and still remain beyond the practical reach of the civilization that discovered it. It can be near enough to know and too far to touch. That is why the next Earth is not merely a discovery problem. It is a scale problem. The universe may give us a target long before it gives us a route. It may show us a world that seems like a second Earth, and then leave us with the unbearable fact that light was able to bring the news, but no human can follow it soon. The planet may become part of human culture, part of science, part of philosophy, part of our sense of cosmic identity, while remaining forever outside ordinary reach. A light year turns hope into distance, and distance into time. This is why the mind has to slow down when it speaks of Earth-like worlds. A planet 20 or 40 light years away may be close enough to become a major scientific target. It may be close enough for future telescopes to examine, but to a human family, a human body, or a human civilization trying to imagine travel, the distance belongs to a different order of reality. The planet may be nearby in a catalogue, and impossibly remote in experience. Both statements can be true at once. That double truth is the source of the unease. This is why the search remains moving, rather than simply bleak. The light year makes the distance worse, but it also makes the achievement of knowing feel greater. If a telescope can gather light from a tiny planet across such a gulf, and if we can read enough from that light to learn something about its air, its orbit, its temperature, or its possible water, then the mind has crossed something the body cannot. Knowledge becomes a kind of travel. Not enough to save us, but enough to change us. That is why the distance feels worse than the number suggests. The number is only the surface. Beneath it are lifetimes, energy, silence, delay, uncertainty, isolation, and the difference between seeing and arriving. Beneath it is the possibility that humanity may find the most important planet ever discovered and still have to remain here, looking at it from one fragile world around one ordinary star. Because if the next Earth is not reachable, then Earth is not just our first home, it is our only practical home, at least for now. Perhaps for a long time. Perhaps for the entire future that matters to us directly. The light year does not destroy the dream of another Earth, but it removes the easy version of the dream. It forces us to treat distant worlds as discoveries, not escape plans. The stars do not become less interesting because they are far away. They become more honest. Their distance tells us that the universe is not arranged around our convenience. Their light tells us that knowledge can cross gulfs our bodies cannot. Their planets, if they exist, tell us that worlds may be common, but homes may still be rare. And the next Earth, somewhere in that darkness, becomes not only a place we hope to find, but a test of how much distance human hope can survive. And once the light year has broken the scale of the journey, the next hope returns to the small red stars where many nearby Earth-sized worlds may be waiting. And where distance is only one of the dangers, red dwarf stars feel promising because they are everywhere. They are small, faint, long-lived stars, far dimmer than the sun, and they make up a large part of the stellar population around us. If the galaxy is a vast, dark forest of suns, red dwarfs are the quiet embers scattered through it by the billions. They do not dominate the night sky with brightness, because many are too faint to be seen without telescopes. But they dominate the count. In the search for nearby planets, they are impossible to ignore. This gives them a special place in the dream of another Earth. If there are many red dwarfs, and if small rocky planets are common around them, then perhaps the nearest potentially habitable worlds will not orbit stars like the Sun. Perhaps they will orbit these small, cool stars, close enough to be detected, close enough to study, and close enough to make the word nearby feel almost meaningful. That is why so many famous exoplanet systems in the search for habitability involve red dwarfs. They are not always the most comforting stars, but they may be the stars most willing to reveal their planets to us. That closeness changes everything. A planet in a close orbit is not merely a smaller version of Earth around a smaller star. It lives in a different relationship with its sun. The star may fill more of the sky. The planet's year may be only days or weeks. Tides may act strongly over long periods. Rotation may slow until the same side faces the star, again and again. Perhaps permanently. The world may become tidally locked, with one hemisphere turned toward daylight and the other facing an endless night. A tidally locked planet is not automatically dead. It could still have an atmosphere thick enough to carry heat around the globe. Winds could move warmth from the day side to the night side. Oceans, if they exist, could help distribute energy. The boundary between day and night, sometimes imagined as a twilight region, might be one of the more stable places. Climate models can produce worlds that are strange, but not impossible. Yet strange is not Earth. On Earth, the whole planet turns through day and night. Weather, biology, sleep, seasons, and temperature all live inside the rhythm of rotation. A tidally locked world would have a different rhythm entirely. One side could receive constant starlight. The other could remain dark for ages. Clouds might gather over the bright side. Ice might accumulate on the dark side. Winds might be permanent and powerful, driven by heat, trying to move through an atmosphere under an alien sky. The second problem is the star itself. A flare above a nearby planet could be part of its weather of survival. The danger is not that every red dwarf planet is impossible. The danger is uncertainty. How strong are the flares? How often do they occur? Does the planet have a magnetic field? Does it have an atmosphere thick enough to absorb radiation? Can that atmosphere survive over billions of years, or is it slowly stripped away? Did the star spend its youth in an active phase that damaged the planet before life ever had a chance? That longevity can sound hopeful. A star that burns for trillions of years gives planets vast amounts of time. If life needs time to begin and evolve, then a long-lived star seems like a gift. But the early history of a red dwarf may not be simple. Some red dwarfs can remain active for long periods. Their young planets may endure intense radiation, strong stellar winds, and conditions that challenge the survival of atmospheres and surface water. A world may be in the habitable zone today, but the important question is, what happened before today? A planet can arrive at the present looking promising in orbit, while carrying a past that made the surface barren. From Earth, we may see the distance and size, but not the scar tissue of its history. We may know a world receives the right amount of light now, but not whether it lost its oceans long ago. We may know it moves through the habitable zone, but not whether the zone was habitable when the planet needed it most. There is also the problem of light itself. Sunlight on Earth is not only energy, it is color, rhythm, and environment. The sun gives broad visible light that shaped plants, eyes, atmospheres, climate, and human imagination. A red dwarf gives a different kind of light, shifted toward the red and infrared, dimmer in visible wavelengths, warmer in color, but not warmer in safety. A planet around such a star may exist under a sky very different from ours. Photosynthesis, if it evolved, might use different wavelengths. The surface colors, shadows, and brightness could feel alien in a way that is hard to capture. This does not make life impossible, but it makes the word Earth-like weaker. This is why the search for another Earth cannot separate planet from star. A world is not just a rock in space, it is a relationship. Earth is Earth partly because of the sun, because of the kind of light the sun gives, the stability it has offered, and the distance at which Earth receives that energy. Around another star, even a planet with similar size and temperature may live inside a different relationship. The star shapes its sky, its atmosphere, its radiation environment, and perhaps the possibility of life itself. And because red dwarfs are so common, this difficulty becomes central to the entire search. If most nearby rocky habitable zone candidates orbit red dwarfs, then the easiest places to find and study may also be the hardest places to trust as true second Earths. They are scientifically precious, but emotionally complicated. They may tell us that life can adapt to strange conditions. They may reveal atmospheres around small worlds. They may show us that planets can survive where we once doubted, but they may not give us the familiar mirror we are hoping for. The nearest promising planets may be the least Earth-like in spirit. That is a strange reversal. The worlds we can study first may not be the worlds that most resemble home. They may be nearby because their stars are common and favorable for detection, not because their environments are gentle. They may be rich in scientific clues, but poor in human comfort. They may answer the question of life before they answer the question of home. They may show that biology can exist somewhere alien while leaving the search for a true next Earth still open. But importance is not the same as comfort. This is where the phrase next Earth becomes harder to use. If a red dwarf planet has the right size and receives the right amount of energy, should it be placed in the same emotional category as Earth? Maybe it should be a candidate. Maybe it should be taken seriously. But if its star constantly reshaped its environment, if its surface is divided between eternal day and night, if its atmosphere is uncertain, if its sky is dim and red, then the comparison becomes strained. It may be an Earth-sized world, not an Earth-like world in the deeper sense. Potentially habitable means the door is not closed. It does not mean the house is built. It does not mean the air is safe. It does not mean oceans are there. It does not mean life has begun. It does not mean humans could survive. It means the world is worth asking about, and red dwarf planets are often worth asking about, precisely because they are common, close, and observable. The beauty of such a system is not that it solves the search. It is that it makes the questions sharper. Multiple worlds around the same small star allow comparisons. One may have lost more atmosphere than another. One may receive more energy. One may sit closer to conditions we would call promising. Together, they can teach us about how planets survive around red dwarfs. But teaching is not the same as confirming as second Earth. The more we learn, the less simple the dream becomes. A fantasy can remain pure because it does not have to answer questions. A real planet must face them all. It must face its star. It must face time. It must face chemistry. It must face atmosphere. It must face observation. It must survive the difference between what we hope and what it actually is. Red dwarf planets are among the first places where the dream of another Earth becomes concrete enough to feel vulnerable. They are close enough to wound the imagination. If the nearest promising planets turn out to be barren, the galaxy does not become empty. But the easy hope becomes weaker. If they turn out to have atmospheres, the search becomes more exciting. If they show signs of water, the dream deepens. If one shows possible signs of life, everything changes. But even then, the question remains: would that make it another Earth? Or would it reveal that life can exist in a place nothing like home? That question may become one of the great questions of the coming era. If life is found around a red dwarf, it could expand our idea of biology while breaking our idea of a second Earth. It could tell us the universe is more alive than we thought, but also more alien. It could give us hope and unease at the same time. It could mean that life is common, but Earth-like comfort is not. That would be a profound and unsettling answer. It would mean we were looking for a mirror and found a stranger. This is why red dwarf worlds belong near the center of the story. They may be our first serious chances to study small, potentially habitable planets beyond the solar system. They may be close enough for future telescopes to examine more deeply. They may become the first worlds where we search for atmospheric signs with real precision. They may answer questions that once belonged only to speculation. And yet, they also remind us that the nearest path is not necessarily the safest path. There is a quiet fear in that. Not a dramatic fear, but the slow disappointment that comes when the universe offers something real, and the real thing refuses to match the shape of our hope. Red dwarf planets may be abundant, fascinating, and deeply important. They may become some of the most studied worlds in astronomy. They may even be habitable in ways we have not yet fully imagined. But they may not give us a second Earth under a familiar sky. They may give us a different lesson. Earth is a partnership with a particular kind of star, a long history, a protective atmosphere, oceans that lasted, a climate that changed without permanently breaking, and life that eventually reshaped the world itself. To find another Earth, we may need more than a nearby rocky planet around the most common type of star. We may need a world whose star has been calm enough, whose atmosphere has survived enough, whose surface has remained gentle enough, and whose time has been generous enough. That uncertainty is not empty. It is alive with possibility. It is why scientists keep studying them. It is why future observatories matter. It is why every atmospheric measurement, every new model, every flare observation, and every planet discovered around a nearby red dwarf becomes part of the larger search. These worlds are not side stories. They are where the question becomes urgent, because they are close enough for us to ask it well. But if the answer from many red dwarf worlds is no, then the search does not end. It moves outward and becomes more difficult. It begins to look more seriously towards stars that resemble the Sun, toward worlds that may orbit at more familiar distances, under more familiar light, with perhaps more familiar rhythms of day, night, climate, and stellar behavior. Those worlds may feel closer to the dream of a true Earth. But because Sun-like stars are brighter, and Earth-sized planets around them are harder to detect, and often farther away from us, the price of familiarity may be distance. That trade is where the next layer of the search begins. Red dwarf planets pull the dream close, then complicate it. They show us that nearby is not enough, that Earth-sized is not enough, that the habitable zone is not enough, and that the star itself may decide the fate of a world. They are among the best hopes we have, but also among the clearest warnings that the next Earth may not be waiting conveniently around the nearest small star. If they are not the answer, the search has to reach beyond them. And if the nearest small red stars cannot easily give us a second Earth, the search begins to turn toward more familiar suns, where the promise may feel stronger, but the distance may grow far worse. There is a quiet comfort in a star like the Sun. Not because the Sun is gentle in every way. It is still a star, a vast sphere of nuclear fire, powerful enough to shape every climate, ocean, wind, and living cell on Earth. But from the point of view of life here, it has been stable in the way that mattered most. It has not changed too quickly. It has not lived too violently. It has given Earth time. And time, again and again, becomes one of the hidden requirements behind the word home. So when the search for another Earth moves away from red dwarf systems and towards stars more like our own, the dream begins to feel more familiar. A rocky planet around a sun-like star is easier for the mind to trust. The light feels less alien. The distance from the star may be wider, closer to the kind of orbital space Earth occupies. The planet may not need to huddle close to a dim red star just to stay warm. It may not be tidally locked as easily. It may live under a day and night cycle that feels less strange, with seasons, clouds, and weather shaped by a more familiar kind of sunlight. The worlds that may resemble Earth more deeply are often the ones that hide better. Around a small, dim star, an Earth-sized planet leaves a larger mark. Around a bright, sun-like star, it becomes a whisper beside a flame. The star overwhelms the planet. The world may be there, orbiting in a beautiful, stable, temperate region, but from many light years away it is almost swallowed by the light that makes it possible. A planet too close to its star can be easier to find because it crosses often. A planet in a more Earth-like orbit may cross only once per year, or not at all from our point of view. To confirm such a planet, observers may need years of data. They may need repeated transits, careful filtering, and long patience. If the planet does not transit, other methods may be required, each with its own limits. A true Earth analog does not announce itself loudly. It moves quietly. That quietness changes the emotional shape of the search. That is a haunting possibility. Both possibilities lead to the same feeling. The more we demand a true Earth, the more the distance grows. Not only physical distance, but observational distance. The search pushes past the nearest simple hopes and into a wider, quieter stellar neighborhood. It asks us to examine stars that may be more sun-like, but not necessarily as close. It asks us to wait longer, measure more delicately, and accept that the planet most worth finding may not be among the easiest worlds to detect. If a planet orbits a red dwarf, many viewers already sense that something may be strange. The star is different, the light is different, the orbit is close, and the caveats feel natural. But when a planet orbits a star that sounds like the sun, the emotional guard drops. The mind fills in blue skies too quickly. It imagines oceans, continents, clouds, perhaps even green land. A sun-like star becomes a shortcut in imagination, even though the planet remains mostly unknown. It is size, mass, atmosphere, chemistry, water, geology, impact history, magnetic environment, rotation, climate feedback, biological change, and time. A planet around a sun-like star may still be too large, too dry, too hot, too cold, too dense, too volatile, too young, too old, or wrapped in an atmosphere nothing like ours. The star can make the dream more plausible, but it cannot make the planet become Earth by itself. A planet around a familiar star feels like the search moving closer to the original dream. Not closer in distance, but closer in resemblance. It feels less like asking whether life could survive under alien conditions, and more like asking whether Earth could happen again. Could a rocky world around a sun-like star hold water for billions of years? Could it develop an atmosphere with long-term balance? Could it keep a stable climate? Could biology, if it began, slowly reshape the planet the way life reshaped Earth? If we placed Earth around another star and tried to detect it from a distance, it would not be obvious in the ordinary sense. It would not shine like a star. It would not announce forests or oceans directly to a small telescope. It would cross the face of the sun only if the geometry happened to align. Its atmosphere, would be a delicate clue. Its biology would be hidden inside chemistry that requires careful interpretation. From far away, even this living world would be a faint problem. So the next Earth may be difficult, not because it is strange, but because Earth-like worlds are subtle. This patience has already shaped the story of exoplanets. The more planets we discover, the more we learn that detection is biased. We first notice what our instruments are best at noticing: large planets, close planets, planets around smaller stars, planets that transit from our point of view, planets that tug strongly enough on their stars. The catalogue is real, but it is not a perfect map of what exists. It is also a map of what is easiest for us to find. If we find many red dwarf habitable zone candidates, it may be partly because those are easier to detect and study. If fewer true Earth analogues appear around sun-like stars, it may not mean they are absent. It may mean they are quiet. It may mean they require longer observation, better instruments, and more difficult methods. The galaxy could contain worlds more like Earth than the nearest red dwarf planets. But those worlds may not be the first ones we can confirm. The universe may force us to choose between closeness and resemblance. A nearby planet around a red dwarf may be easier to study, but harder to call Earth-like. A farther planet around a sun-like star may feel more familiar, but be harder to observe and much harder to imagine reaching. The closer one may be strange, the more Earth-like one may be far. This is not only true in astronomy, it is true in ordinary life as well. The more specific the thing we are looking for, the farther we may have to search. A common object can be found close to home. A rare combination may require distance. Earth is not one condition, it is a combination. If that combination is uncommon, then the next world that satisfies it may not be one of the nearest planets. It may not be one of the first 1,000 we study. It may not be in the first systems that feel emotionally convenient. A sun-like star with a truly Earth-like planet would be an extraordinary find. But if the nearest one lies dozens, hundreds, or even thousands of light years away, then the discovery would come with the same ache we have felt before, only sharper. It would be more familiar than a red dwarf world, more emotionally powerful, perhaps more like the mirror we are searching for. But its greater resemblance would not make it closer. It might make it feel farther, because it would be more painful to know what we cannot reach. If a distant planet is clearly alien, then distance becomes part of its alienness. It belongs to the category of things we study but never need. But if a world truly resembled Earth, if it had oceans, clouds, a stable atmosphere, perhaps signs of life, then distance would hurt more. The more it looks like home, the more the separation matters. A second Earth across a large gulf would not feel like a curiosity. It would feel like a door that exists, but cannot be opened. The red dwarf worlds ask whether life can exist in strange conditions. The sun-like worlds ask whether our own kind of planetary story can happen again. They ask whether Earth is rare among all stars, or only rare among the stars easiest for us to study. They ask whether the kind of light that warmed our oceans has warmed other oceans somewhere else. They ask whether another world has had enough calm time for chemistry to become life, and for life to become part of the planet. Hope can survive strangeness by keeping distance. It can say, "This world is interesting, but not home." But a more familiar candidate pulls the imagination closer. It invites comparison. It makes the viewer wonder not only whether life could exist, but whether another sky might truly resemble ours. It makes the distance feel personal. A second Earth around a sun-like star is not just another planet. It is a possible answer to the deepest version of the question. A clue can be close and still incomplete. An answer may require the right conditions lined up in a way that pushes the search farther outward. It may require looking beyond the nearest red dwarfs, beyond the easiest transits, beyond the first exciting candidates, It may require seeing through the glare of brighter stars, waiting through long orbital periods, and building instruments capable of reading faint atmospheric signatures from worlds that barely separate themselves from their suns. That kind of astronomy may one day find the world we are looking for. Perhaps it will be closer than we fear. Perhaps a nearby sun-like star will host a planet that turns out to be more Earth-like than anything we currently know. Perhaps future telescopes will reveal atmospheres around small rocky worlds, and one of them will show a chemical balance that makes the scientific world pause. Perhaps the next Earth is not impossibly far, only difficult to see. The true next Earth may not be close. It may be somewhere that current instruments can barely reach. It may be hidden in data not yet collected. It may require decades of observation. It may orbit a star that is ordinary in every way, except that one small planet around it became extraordinary. It may be distant enough that its light takes many human generations to reach us. It may become known to us as a world that already belongs to the past by the time we see it. A world can be home-shaped and unreachable. It can be kind in its own system and useless to us as a refuge. It can be real and still never receive a human visitor. It can become one of the most important discoveries in history while remaining a point of light, a spectrum, a set of models, a place known through distance rather than presence. A red dwarf world that turns out strange may disappoint the dream, but the disappointment creates distance in the imagination. A sun-like, Earth-like world far away would do the opposite. It would invite the imagination in, then keep the body out. It would make the universe feel less empty and more unreachable at the same time. It would prove that Earth is not alone, while reminding us that not alone is not the same as together. And perhaps that is what the search is truly moving toward. Not a replacement, not an escape, not an easy future, but a revelation. The next Earth, if found around a more familiar sun, would not reduce the importance of our planet. It would increase it. It would show that Earth-like conditions can happen elsewhere, but also that distance can turn even the most hopeful discovery into a lesson in humility. We would know the universe can make another home while still being forced to care for the only one we can reach. That is why the distance between us and the next Earth may be worse than we think. It may not be the distance to the nearest candidate. It may be the distance to the nearest candidate that survives all the questions. The nearest one with the right star, the right orbit, the right atmosphere, the right water, the right history, the right stability, and perhaps the right signs of life. The nearest world that is not just possible, but convincing. The search for more familiar suns therefore does not make the story easier. It makes it more serious. It asks us to accept that the most Earth-like planets may be harder to find, harder to study, and harder to reach than the first hopeful worlds around nearby red dwarfs. It asks us to separate the comfort of resemblance from the reality of distance. It asks us to understand that a world can feel closer to Earth in nature while being much farther away in space. Because once we begin looking for true Earth-like worlds around stars that feel more familiar, the search no longer only asks whether such planets exist. It asks whether the universe placed the nearest one close enough for us to know in detail, or so far away that even discovery would feel like looking at home through a locked door. And before any world can become more than a distant hope, we have to face another problem. Seeing a planet is not the same as knowing it. That difference is easy to forget. From Earth, the word discover feels complete. We hear that a planet has been found around another star, and the mind immediately turns the discovery into a place. It gives the planet a surface, a sky, a horizon, perhaps clouds moving above alien oceans. The word found makes it feel as if the world has stepped out of hiding and is now waiting in the open. But most exoplanets are not found in that simple way. They are not seen like photographs of Mars or Jupiter or Earth from the Moon. They are inferred from faint changes in light, from tiny motions, from signals so delicate that the world itself remains almost completely unseen. A planet can be discovered while still being hidden. That is the strange beginning of knowing another Earth. This matters deeply when we speak about the next Earth. A true Earth-like planet would not be confirmed by a feeling. It would not be confirmed by a hopeful headline. It would have to be known through evidence, and evidence across light years is slow, partial, and difficult. A planet can seem promising at first and become less promising later. It can be called Earth-sized before we know whether it has air. It can be placed in the habitable zone before we know whether water exists. It can be called rocky before we understand its surface. It can be famous before it is truly familiar. A world may be 10 light-years away in space, but much farther away in certainty. We may know its orbit and still not know its sky. We may know its size and still not know its pressure. We may know its star and still not know whether the surface has survived that star's history. The planet may be near enough for light to reach us, yet hidden behind layers of uncertainty that no spacecraft has crossed and no telescope has fully removed. This is why the search for another Earth is not only about finding candidates. It is about slowly turning candidates into worlds. This is why seeing a planet is not the same as knowing it. Even when a distant exoplanet is directly imaged, which is rare and usually easier for large, young, bright planets far from their stars, the image may still be only a dot. A dot can be powerful. It can prove that the planet is there. It can let scientists study brightness, color, and perhaps changes over time. But a dot is not a landscape. It does not tell us whether a shore exists. It does not show rain. It does not show whether a planet is dead, living, or only pretending to be familiar from far away. A small amount of evidence can support a large amount of imagination. This is not foolish. Imagination is part of why the search matters. Without imagination, a distant planet would remain only a number in a catalogue. But imagination must be held gently, because the universe is very good at refusing our pictures. A planet that looks temperate in a simple model may have a crushing atmosphere. A planet with the right size may be dry. A world with possible water vapor may not have oceans. A chemical hint may have more than one explanation. The next Earth cannot be allowed to become a fantasy before it becomes a finding. To truly know another Earth, we would need to understand more than where it orbits. We would need to know whether it has an atmosphere and what that atmosphere contains. We would need to know whether pressure allows liquid water on the surface. We would need to know whether the temperature is stable or only briefly favorable. We would need to know whether its star is calm enough, whether its climate can endure, and whether chemistry on the planet points toward life or only toward lifeless processes that imitate the signs we hope to see. A biosignature is not a single magic word written in light. It is a pattern that has to survive every other explanation. This makes the search feel slower than hope wants. If a possible next Earth shows a strange atmosphere, the careful response is not immediate celebration. It is deeper investigation. What kind of star does it orbit? What is the planet's mass? How much radiation does it receive? Could the atmosphere have formed without life? Could the signal be contamination, noise, or a misread feature? Are there clouds hiding the true composition? Are there seasonal changes? Does the chemistry stay stable, or does it shift? At first, there may be a candidate, then a better measurement, then an atmospheric hint, then disagreement, then another telescope, then a stronger signal, then new models, then a possibility that becomes harder to dismiss. The world may become more real to science over years or decades, not because it moves closer, but because our understanding slowly closes the gap. The discovery of another Earth may feel less like opening a door and more like watching a shape appear through fog. This is why the next Earth may remain uncertain long after it is discovered. The word discovered would tell us that a planet exists. It would not necessarily tell us whether it is a home, a corpse, a laboratory, a warning, or a miracle. A distant world can be real and still resist meaning. It can have a catalog name, estimated size, orbit, and star, and still remain almost entirely unknown in the way that matters to the human imagination. This is very different from the way science fiction often treats planets. In a story, a ship arrives, scans the world, and knows within moments whether it can support life. The planet becomes immediate. But real exoplanets are not immediate. They are distant systems of evidence. We do not arrive above them. We wait for their light. We do not scan their forests. We analyze shadows. We do not hear their storms. We read spectra. The romance of exploration is still there, but it is quieter, more patient, and more fragile. The next Earth may be a place no one sees clearly for a very long time. That makes the search feel more human, not less. Humans have always lived between what they know and what they hope. Astronomy simply stretches that space until it becomes cosmic. We look at a tiny signal and ask what kind of world could have made it. We compare it with Earth, not because Earth is the only possibility, but because Earth is the only living planet we understand. Every interpretation begins here, in the air we breathe, in the water we know, in the sky that taught us what a world can be. We may miss what does not look familiar. We may overvalue what resembles us. We may search for gases that life on Earth produces, while another biosphere might create different signs. We may expect surfaces like ours, while life elsewhere might hide in oceans beneath ice, or in environments our instruments cannot easily read. The search for the next Earth is therefore not only a search outward, it is also a test of how much we can loosen our grip on Earth, while still using Earth as our guide. This is why future telescopes matter so much. They are not just machines for finding more planets. They are machines for reducing mystery. A more powerful telescope may separate a planet's light from its star. It may study atmospheres more clearly. It may detect molecules that are currently beyond reach. It may observe changes over time. It may help distinguish a dry world from a wet one, a thick atmosphere from a thin one, a promising candidate from a false hope. Every photon still has to travel. Every signal still comes faint and delayed. Every measurement still passes through noise, interpretation, and uncertainty. The telescope improves our reach, but it does not turn the planet into a nearby place. It makes the distant world more knowable, not more touchable. That distinction has followed us through the entire journey, and it becomes sharper here. We often talk about finding worlds as if they become part of us once we name them. But a distant planet does not belong to us because its light enters our instruments. It does not become a destination because it becomes known. It does not become a backup because we can model it. It remains itself, separate, moving through its own history, under its own star. The more we know, the more we may respect that separateness. The next Earth, if found, would still be another world. This realization changes the emotional meaning of knowledge. At first, knowing another Earth exists would seem like comfort. It would answer the loneliness. It would prove that Earth is not the only world of its kind. But if that knowledge remains purely observational, if the world is unreachable and partly unknowable, the comfort would be mixed with distance. We would know enough to feel wonder, but not enough to feel closeness. We would know enough to name the hope, but not enough to live inside it. And yet, this longing is not meaningless. It is one of the forces that drives science. The desire to turn distant light into knowledge has already changed our place in the universe. It has transformed stars from points into suns, suns into systems, systems into possible homes, and possible homes into questions about life itself. The next Earth may be far away, but every step toward knowing it teaches us something about planets, stars, atmospheres, and the fragile conditions that made this world possible. A planet that turns out not to be Earth teaches us what Earth is not. A signal that turns out not to be life teaches us how false hope can form. A world without atmosphere teaches us about loss. A world with too much atmosphere teaches us about excess. A world around a violent star teaches us about survival. A world that remains ambiguous teaches us humility. Each non-answer shapes the future answer. That is why seeing is the beginning, not the end. The first sight, whether direct or indirect, gives us a target. The real work begins afterward. The planet must be revisited in data, compared with models observed in different wavelengths, measured again and again, and interpreted with enough caution to avoid turning hope into certainty too soon. The more important the world, the slower we may need to become. It could make us believe the search was solved when it was not. It could make us imagine a future refuge where none exists. It could make us misunderstand the rarity of our own planet. It could create comfort from incomplete evidence. The search for another Earth needs wonder, but it also needs restraint. The name Earth must be earned. If one day a planet truly earns that comparison, the moment will be greater because of the caution that came before it. It will not be a headline built on loose resemblance. It will be a world supported by layers of evidence, a distant planet that has survived question after question and still looks, in some deep way, like Earth. Not identical. Not perfect, not a replacement, but close enough to change the human story. Some beginnings will fade. Some will become stranger. Some will become more promising. Some may wait for instruments not yet built. The search is not a straight road towards certainty. It is a slow opening of the dark, where each world appears first as a trace, and then, if we are patient, as something more complex. It may orbit a red dwarf, a sun-like star, or some star we have not yet learned to value properly. It may be unlike Earth in ways that still allow life, or like Earth in ways we cannot yet prove. The only honest position is to keep looking carefully, with imagination awake and certainty restrained. That is where the search grows more painful. Even if the evidence becomes stronger, even if a world begins to look more and more like the answer, the next question waits behind it. The planet may be known, named, studied, and perhaps even recognized as the best candidate for another Earth humanity has ever found. But the distance would remain. The light year would remain. The silence between stars would remain. And once that truth settles in, the next question becomes impossible to avoid. Even if we found the next Earth, could we ever go there? Until now, the next Earth has been a mystery of distance, evidence, and resemblance. We have asked what makes a planet truly Earth-like, what the habitable zone really means, why nearby stars can still be impossibly far, why red dwarf worlds may be strange, and why seeing a distant planet is not the same as knowing it. But the moment we imagine the evidence becoming strong, the story shifts from astronomy into something much more difficult. Suppose, for a moment, that the search succeeds. Not in a vague way, not only with a rocky planet in the right orbit, not only with a headline that says potentially habitable, but with something much stronger. A world around another star begins to look genuinely Earth-like. Its size is close enough. Its star is stable enough. Its orbit is promising. Its atmosphere has the right kind of balance. Water may be present. The data grows stronger year after year, until scientists begin to speak with a careful but historic confidence. The planet would not move closer because we understood it better. Its oceans, if they existed, would not become reachable because we detected them. Its atmosphere would not become breathable to us because we measured it from Earth. Its star would still be separated from us by light years. The world would remain where it had always been, turning quietly through its own years while our knowledge of it traveled across the dark and arrived as light. On Earth, discovery and travel belong together. When a new island was mapped, ships could try to reach it. When a mountain was seen, climbers could plan a route. When a continent was crossed, people moved through forests, deserts, rivers, and coastlines, slowly turning the unknown into a place. Distance could be dangerous, but it belonged to the same planet. It could be crossed by bodies, it could be endured by generations, and still remain inside the living world. This is why reaching another Earth is not only an engineering problem, it is a biological problem, a social problem, a psychological problem, and a moral problem. How do you keep human bodies alive for a journey that might last longer than a lifetime? How do you protect them from radiation? How do you grow food without a planet? How do you maintain machines that cannot be replaced from Earth? How do you build a society that does not collapse inside a sealed vessel? How do you ask people to begin a journey whose destination they may never see? If the next Earth is close by, astronomical standards, perhaps a robotic probe could someday be imagined. A small craft, accelerated to extraordinary speed, might cross to a nearby star after decades. It might send back data, if it survives, if it can communicate, if it can slow down or at least fly past at the right moment. That alone would be one of the greatest achievements in human history. But sending a small probe is not the same as sending humans. A machine can be tiny. A machine does not need air. A machine can tolerate silence. What happens if the people born on the ship no longer want the mission? What happens if the destination turns out to be less habitable than expected? What happens if a later observation from Earth, received after launch, shows that the planet's atmosphere is not as promising as once believed? What happens if the ship society changes, divides, forgets, or reinterprets its purpose? What happens if the vessel itself becomes the only home its people understand, and the planet ahead becomes a myth? The speed of light remains the great boundary. Energy remains real. Impacts with dust at high speeds become dangerous. Radiation remains dangerous. Slowing down at the destination is its own problem. Communication delay remains unavoidable. A ship traveling to another star must not only go fast, it must survive going fast, and then somehow become useful when it arrives. The faster the journey, the more extreme the energy and danger. The slower the journey, the more time becomes the enemy. This is why the next Earth cannot be treated like a backup plan in the simple sense. A backup plan must be available when the first plan fails. It must be reachable, usable, and ready within the time of danger. A planet light years away is none of those things for any crisis we can imagine on Earth today. It cannot help us with climate, war, disease, impact risk, social collapse, or environmental damage in any immediate way. Even if it is real, even if it is beautiful, it cannot catch us quickly, because the dream of another world can become dangerous if it makes this world feel replaceable. If people imagine the galaxy as full of spare Earths, then Earth becomes less urgent in the imagination. But the truth is the opposite. The farther away the next Earth is, the more precious this one becomes. The harder it is to travel, the less another world can function as an escape. The more complicated habitability becomes, the more extraordinary our present home appears. That difference matters. A distant Earth-like planet may change science forever. It may prove that our world is not unique. It may show that life can arise elsewhere. It may become a spiritual, philosophical, and scientific turning point. But unless it is reachable in a practical way, it does not become a substitute. It becomes a mirror. It shows us what a habitable planet can mean by reminding us how difficult one is to reach. This is where the distance becomes almost moral. The universe may not forbid another home from existing, but it may place that home so far away that we are forced to confront our responsibilities here. We cannot treat distant worlds as exits from the consequences of living badly on this one. We cannot assume that discovery equals rescue. We cannot look at a possible second Earth and use it as permission to neglect the only world under our feet. A ship to another Earth would be a tiny closed ecosystem. It would need recycling, balance, restraint, repair, and long-term thinking. The same principles that matter on Earth would matter there in more unforgiving form. Waste could not be ignored. Air could not be assumed. Water could not be taken for granted. Social trust could not be treated as optional. The ship would make visible what Earth often hides from us, that survival depends on systems remaining whole. That is not the kind of answer that fits the simplest dream. The simple dream says, find another Earth, build a ship, go there. The deeper truth says, if we ever become capable of reaching another Earth, it may be because we first learned how rare and fragile habitable environments are. We learned that a living world is not a disposable platform. We learned that distance is not a bridge. We learned that a second home, even if real, cannot replace the first. Could humanity survive long enough to attempt it? Could it preserve knowledge across generations? Could it build machines that endure? Could it cooperate beyond the length of political cycles and individual lives? Could it carry the memory of Earth without destroying the new world it finds? If the next Earth is inhabited, even by simple life, what right would humans have to arrive? If it is lifeless but habitable, what responsibility would come with changing it? A living world would not be empty simply because humans could land there. A planet with its own biology, even microbial, would have its own history. It would not be a blank canvas. It would be another branch of life, perhaps completely independent from Earth. To treat it only as a destination would be to miss the most profound part of the discovery. A true second Earth with life would not just be a possible home. It would be a second Genesis. If the planet had no life, it might seem simpler. But even then, transforming another world would be immense. Atmosphere, climate, chemistry, and ecology do not become stable because people wish them to. A planet that looks Earth-like from afar may not be immediately livable. It might require protection, habitats, and machines for centuries. It might be dangerous in ways the data did not reveal. Gravity might differ. Air might be wrong. Microchemistry might be toxic. Weather might be extreme. The surface might be more hostile than the word Earth-like ever suggested. Earth-like does not mean human-ready. It means similar in some important ways. There may still be no breathable air, no edible biosphere, no safe microbes, no stable environment for our bodies, and no simple way to build a civilization. Even a promising planet might require habitats, suits, filters, medicine, and endless adaptation. The dream of walking freely under an alien sky may remain a dream long after arrival. The next Earth, if found, may not be a destination for us at all. It may be a destination for thought, for science, for future probes, perhaps for descendants beyond any timeline we can honestly imagine. It may be a world we study rather than settle. A world we protect rather than occupy. A world that expands the meaning of life without becoming a human refuge. Not every world has to become useful to be meaningful. A second Earth would matter even if no one ever went there. It would matter because it would show that Earth is not an impossible accident. It would matter because it would prove that the universe can create more than one world where complexity takes root. It would matter because it would give humanity a mirror across the dark. But the mirror would not be a doorway. This is why the question, could we ever go there, has no simple answer. In principle, perhaps. With enough time, enough technology, enough energy, enough stability, and enough reason, perhaps some future civilization could send machines or even people toward another star. But in the world we know now, for the humans living today, the next Earth is not a practical destination. It is a distant possibility, one that may remain outside human reach long after it becomes part of human knowledge. This is not failure, it is scale. It is the natural result of being small creatures on a small planet, able to think across the galaxy, but not yet able to move across it. The mind is faster than the ship. Light is faster than the ship. Hope is faster than the ship. And so the next Earth, if it appears in our instruments, will first belong to the mind, not to the body. That last thought is painful, but it makes the search more truthful. We are not looking for an easy escape. We are looking for understanding. We are asking whether the kind of world that made us can happen again. We are asking how rare comfort is in a hostile universe. We are asking how far life can spread, how many planets can hold it, and whether the galaxy contains other places where oceans, air, chemistry, and time have met in the right way. The next Earth may teach us that home is possible elsewhere, while reminding us that home is not something easily reached. It may tell us we are not cosmically alone, while leaving us physically isolated. It may make the universe feel richer and Earth feel more fragile at the same time. It may give humanity one of the greatest revelations in history, and still leave every human being dependent on the planet where the story began. The dream does not disappear when we admit this. It becomes quieter and more serious. It stops being a fantasy of replacement and becomes a meditation on rarity, distance, and responsibility. It teaches that the stars may contain wonders beyond imagination, but that wonder does not cancel the value of what is near. It teaches that discovery can expand the soul without expanding the safe ground beneath our feet. A silence filled with awe, longing, and the strange knowledge that somewhere across the dark, another world may exist under another sun, while we remain here, breathing the air of the only planet that has ever carried us. And if even the next Earth cannot become a real refuge, then the final question turns back toward the world beneath us. Why Earth may be the only home that truly matters. That question does not make the search smaller, because the search for another Earth has never truly been only about leaving this one. It has been about understanding what a home is in a universe where most places are not homes at all. It has been about looking outward through the darkness, past the planets, past the sun, past the nearest stars, and asking whether the conditions that made us could happen again somewhere else. But the farther the search travels, the more it reveals something quietly uncomfortable. The next Earth, even if it exists, may not belong to us in the way this Earth does. It is a vast field of separations, and Earth is the one place where separation stops. Here, for now, we are not visitors. We are not protected by metal walls. We are not sealed behind glass. We are not carrying our atmosphere in tanks or recycling every breath through machinery. The world around us is not an external system we must constantly fight against. It is the system that made us. The air, the oceans, the soil, the pressure, the gravity, the temperature, the chemistry, and the living networks of the planet are not background details. They are the reason a human body can exist at all. That is why Earth is different from every other world we have found. Not because it is the largest, not because it is the most dramatic, not because it is the center of the universe, but we already stand on one. You do not know Earth only because you have seen pictures of it from space. You know it because your lungs trust it before your mind speaks. You know it because weather touches your skin, because water can be held in your hands, because gravity feels normal, because morning light arrives without needing explanation. The world is not merely observed, it is inhabited. It surrounds every moment so completely that it almost disappears from attention. A miracle repeated daily can begin to look ordinary. That may be one of the quietest dangers of living on Earth. The planet is so intimate that it becomes invisible. Air is always there until it is not. Water is ordinary until it disappears. Soil is beneath our feet until we ask what it took to make it fertile. A stable climate feels like background until it begins to shift. The living world seems endless until we see how fragile its systems can be. Earth hides its rarity by being constant enough for us to forget it. The search for another Earth breaks that illusion. Every candidate reminds us of what must go right. A planet can be the right size and still fail. It can sit in the habitable zone and still be barren. It can orbit a common red dwarf and face radiation, tidal locking, and atmospheric loss. It can circle a sun-like star and still be too large, too dry, too hot, too cold, or too distant for us to understand clearly. It can have a promising signal that later becomes uncertain. Again and again, the galaxy teaches that almost Earth is not Earth, and almost home is not home. A distant second Earth would be one of the greatest discoveries humanity could ever make. It would answer a question older than science in its modern form. It would tell us that the universe has made more than one world where the conditions of home can emerge. It would change philosophy, biology, astronomy, and the way people look at the stars. But it would not immediately change the ground beneath our feet. It would not give us another atmosphere to breathe. It would not repair this one. It would not replace the oceans, forests, ice, soil, and living systems that already hold us. A second Earth would expand meaning. And if we do not find one, the lesson becomes even sharper. Then, Earth may not only be our only reachable home, it may be our only known example of a living world in all the darkness we have searched. The silence would not prove that life is absent elsewhere, but it would make the known fact of Earth even more powerful. One planet, around one ordinary star, carrying oceans, storms, continents, bacteria, forests, animals, memory, language, and minds that can look back at the universe. That is not a small thing. It is the center of every human story. From space, Earth is physically small. It is a pale world near a medium-sized star in one galaxy, among many. It is not large enough to dominate the solar system, let alone the Milky Way. But importance is not the same as size. A seed is small. A cell is small. A voice is small compared with a mountain, but it can still carry meaning. Earth is small in space, but immense in consequence, because it is the only place where we know matter has awakened into life that can ask where else life may be. Here means reach. Here means breath. Here means responsibility that cannot be delayed into science fiction. Here means the planet is not a concept, not a target, not a candidate, not a spectrum, not a line in a catalogue. It is a living environment with real consequences. The search for another Earth can inspire us, but it cannot replace the need to understand and care for the one world that is not separated from us by light years. This is where the calm fear of the title becomes clear. The distance between us and the next Earth is worse than we think, not only because light years are large, but because distance removes usefulness. A planet may be real and still unable to help. It may be Earth-like and still inaccessible. It may be alive and still unreachable. It may be the answer to one cosmic question while leaving every practical question on Earth untouched. There is also a strange comfort in it. If Earth is the only home that truly matters to us now, then our attention does not have to be divided by fantasies of easy escape. The future may reach outward, and perhaps one day humanity will send probes or even descendants toward another star. But the center of human life remains here. The search for the next Earth does not pull meaning away from this planet. It returns meaning to it. Every distant world becomes a comparison. Every failed candidate becomes a reminder. Every uncertain atmosphere becomes a lesson in how rare certainty is. Every light year becomes a measure of how close we already are to the only home we know. And miracles of conditions should not be treated casually. The word miracle does not have to mean something outside nature. It can mean something natural and still astonishing. Earth is natural. Its oceans obey physics. Its atmosphere follows chemistry. Its life evolved through biology and time. Nothing has to break the laws of the universe for Earth to be extraordinary. The extraordinary part is that so many lawful things happened together in a way that made a world like this possible. A second Earth would also be natural and still astonishing. This is why the search should continue. To say Earth may be the only home that truly matters is not to say we should stop looking. The search for other Earths teaches us how planets work. It teaches us how stars shape their worlds. It teaches us about atmospheres, water, chemistry, and the possible forms life might take. It widens the imagination and humbles the ego. It shows us that Earth is not the center of everything, while also showing us that Earth is the center of us. Those two truths can live together. Earth is not cosmically central. Earth is humanly central. The universe does not revolve around our planet, but every human thought, every memory, every language, every song, every city, every question about the stars began here. From the point of view of the cosmos, Earth is one world among many. From the point of view of life as we know it, Earth is the only shore. The search for the next Earth stretches our vision beyond that shore, but it does not remove our dependence on it. Perhaps that is the most honest ending. The next Earth may exist. The next Earth may be far. The next Earth may never become ours. And even if it is found, Earth remains the world that made the search possible. That is why a calm space documentary about distance becomes, in the end, a documentary about home. We began with the idea of another world, somewhere beyond the sun, perhaps waiting around another star. We followed the meaning of Earth-like, the uncertainty of the habitable zone, the strange promise of nearby red dwarfs, the difficulty of sun-like stars, the limits of seeing, and the painful question of travel. Every path led outward. Every path also returned. The next Earth is a question written in the stars. This Earth is the answer we are already living inside. That does not mean Earth is safe forever. A home can be real and fragile at the same time. A planet can be generous and still vulnerable to what its inhabitants do. Earth has survived impacts, ice ages, volcanic crises, and changes beyond human memory. But human civilization is not as durable as the planet itself. We live within narrow conditions. We depend on stability. We depend on systems larger and older than us. To call Earth home is not to claim it cannot be harmed. It is to understand that harm has nowhere simple to escape to. The stars may hold other worlds, but they are not emergency exits. They are witnesses. They show us scale. They show us possibility. They show us how much we do not know. They show us that the universe is rich enough to make planets by the billions, and perhaps rare enough that another true Earth may still be distant beyond human reach. They make our world look small, but not meaningless. They place Earth in darkness, and somehow make its light more intense. Maybe that is the final feeling the search leaves behind. Not despair, not certainty, but a quiet seriousness. The seriousness of knowing that another Earth may exist and that the distance to it may be worse than we think. The seriousness of knowing that our own world is not a practice version of home, not a temporary platform before the real future begins elsewhere, but the living center of everything human beings have ever been. The seriousness of looking at the stars and understanding that wonder is not the same as rescue. Wonder opens the mind. Rescue still begins here. If there is another Earth, it is a gift to knowledge. If there is life elsewhere, it is a revolution in meaning. If there are many habitable worlds, the galaxy is richer than we dared to hope. But none of those possibilities makes this planet disposable. None of them makes the atmosphere above us less important. None of them makes the oceans less real, the forests less alive, the soil less necessary, or the future less dependent on what happens here. The next Earth may change how we see the universe. This Earth determines whether we remain here to see it. That is the deepest reason the distance matters. It does not only separate us from another possible world, it separates fantasy from responsibility. It separates the dream of escape from the reality of survival. It shows that the search for a second Earth is not a way to avoid caring about the first. It is one of the strongest reasons to care more. Because after all the light years, all the candidates, all the uncertain atmospheres, all the red dwarf worlds, all the sun-like stars, all the possible oceans we may never touch, the truth remains simple. We are already on the planet we were hoping to find. A world with air, a world with water, a world with weather, a world with life. A world close enough not to be called close at all, because it is beneath us, around us, inside every breath. The distance between us and the next Earth may be worse than we think, but the distance between us and this Earth is nothing. There is no gulf to cross, no light year to wait through, no signal to decode before we know it is real. The proof is immediate. It is the pressure in our lungs, the gravity under our feet, the sky over our heads, and the fragile living world that has carried every human dream of the stars. That is why Earth may be the only home that truly matters. Not because the universe is empty, not because the search is hopeless, but because home is not only a place that exists. Home is the place that holds you. And for now, across all the known darkness, Earth is the only world that holds us. Thank you for watching this calm journey into the search for the next Earth, and the frightening distance that may separate us from the nearest world like our own. If you enjoyed this documentary, subscribe for more quiet space stories like this. Leave a like if you want more deep journeys into the mysteries of the universe, and write in the comments where you are watching from. Tonight, you are watching the Just About Space channel, talking about the distance between us and the next Earth is worse than you think. Sleep well and keep looking up. Good night.